It's kind of funny. The professional lesson I've learned is something that everybody should know, and it has really to do with being honest and respecting others' experience. Not necessarily the age, but the experience they have. It's when you're talking to customers, they know as much as you do, if not more, about what they're doing, what they're making. And the worst thing you can do is tell them, like, oh, you're doing it wrong. Well, you've been in the business for 5 years. They've been in the business for 30 years. Maybe they know a little bit more. So it's respecting that. And the experience is not just at the professional level. It's at all levels. I've learned the most from working with plant operators without the engineers present, just trying to understand what they do, what they know, and what's important for their part of the process. Generally, I'll ask them, what do you think the problem is when I'm troubleshooting? And they'll be the first ones to say, oh, well, you know, it's this. And I tell the engineers, but they won't listen to me. So it's interesting to go back and say, well, you know what, I've talked to you guys on the floor. We think it's this. And I'll just join in with that whole series. So it's really respecting that, because if you don't, you're lost. Anybody at any level can make your product fail. If you engage in them, if you trust them, if they trust you, it really makes a big difference. And respect is all about that. It gets into building the relationship with your customers. And that's not easy to do with a lot of people, because you have to be comfortable. You have to be comfortable with people. And what I've seen is if you do that, you become part of this team mentality, not a structured team, but a team mentality where you're all focused on the same goal. I'm not going to troubleshoot a product thinking about how I can point the finger at their process versus them trying to point the finger at my product. We work together to fix the problem. Sometimes it starts off as a half-hour venting, but once you get beyond that, it's let's go and fix the problem. We're all here for the same reason. We'll do whatever it takes to make it work. And that's really hard to really learn in school, but it's easy once you get into the applications, get into the customers, work with your suppliers, and really fine-tune what you know into what they do. So that's pretty much the most valuable lesson. It's always been a fun, and that's the part of the job I like the most. Developing products are one thing, but when you can go out and help your customers make them work, and if they don't work, help them troubleshoot the problems and understand what you need to do to go back if you have to make an adjustment, to come back and say, yeah, we'll fix that for you because I know now exactly what you need. It's not what's on the spec, but it's what you need for the application. So that's the fun part. It's kind of funny, I don't like, suits are usually weddings and funerals. And no problem. Matter of fact, when I took the picture actually my son-in-law took the picture, I had my jeans on here. We were over his house for, I think Easter, Well, it's a little tricky to, why you would choose one industry over another. But one of the things I've seen is rubber is not too difficult to understand the basics. It's extremely challenging to be an expert in it. It's not a static science. We're not talking about, we got tweaks on tire compounds. We're going into everything and anything that you wouldn't have even thought about for rubber, 20 years ago. I mean, everything from, high voltage insulators. The applications are amazing with rubber, and they go in all different areas. There's tremendous amounts of healthcare applications for elastomers these days. LEDs, optically clear elastomers that maintain optical clarity over a very long period of time, whether it's in a solar cover, solar panel cover to these LED billboards out in the street. There's just an amazing things. I mean, when you look at the technology and how things have changed over years, something as simple as a household spatula went from metal to plastic, which melted. Now they're all rubber because you can dip them in oil and put them anywhere you want. They're good to about 400 degrees Fahrenheit. So the technology has really changed. It's a lot more exciting than what people might have thought about what we used to call black rubber in the organic business. There's just a myriad of implications. So what I try to encourage people to do is look around, see what's out there, see what could be an elastomer or soft, and think about what the environment is. What's the apparent environment? What do you think? Is it an articulated bus that has those accordion pleats between the two panels? Well, that's an elastomer. If it's one area, it might be Hypalon. If it's another area, it's silicone. So it's amazing to see that. You think, wow, I never even thought about that. Where does that come from? What's the environment? What's important for that? For trains and stuff, everything has to be flame retardant. There's another implication of speciality within the elastomer industry. So there's, once you get into it, once you understand the basics, you can spread out quite a bit. Customers who make things, or our customers who make things out of elastomers, make everything. I get calls from people who are coating wire one day, and then I'll get a customer who's putting a seal on a space vehicle or a satellite system. And you're saying, wow, I didn't even know that was there. And you get to really see kind of the applications. And you get a guy saying, hey, I'm going to make this sheet of silicone rubber that's going to go in to make an anti-stick on top of your cookie sheets. Okay, yeah, we can do that too, because there's food grade, there's healthcare grades, there's medical grades, and then the real high industrial grades, abrasion-resistant grades. So it's not a small industry. It's a common name for an extremely large industry with a number of different elastomers that get used quite a bit in day-to-day life, whether it's a cowling on a camera lens to parts that you never see, to little channels for tear ducts to keep them open where people have diseases that might close up tear ducts. And you get these little molded parts that fit inside that. It's just amazing. 2 earplugs, if people don't want to listen to you anymore. I was always interested in chemistry, but didn't want to work in a lab. I wanted to get it, and influence real life, large stuff. That was in high school. I explained to an advisor once what I was interested in. I said, I like chemistry. I don't want to work in a lab. I want this. I made up a list. He said, oh, that's chemical engineering. I said, oh, really? I said, I never heard of that before. Back then, 40 years ago, or 45 years ago almost. And I said, okay, that's what I want to do. I was amazed that at 17 years old, I picked a field that I enjoy now, many years later. But, if you have an inquisitive mind, if you think about how I can make that better, elastomers is one avenue to do that in because you have a lot of flexibility. Plastics are kind of the big boys. There's a lot less variation in what you're working. You're trying to design products to work within a family. Here we can design the elastomer and the formulation and the compound to work for an application. So you have a completely different tool set. And it's, if you like to build things, if you like to analyze things, if you like to say, I bet you I can do that better, that's where you can use elastomers. If you have a smartwatch with a band, it's an elastomer. If you have a coating or a cover on your iPad, an iPhone, those are elastomers. They have very specific needs, shock absorption, tack, no tack. It's textile as well as function. So you're balancing a lot of what looks good, feels good, versus what performs well. So you have to have an inquisitive mind, I think. You have to want to say, how can you do this better? And that's what I see, what makes it different and what made me get into it and what makes me enjoy it today is helping people out that are having problems in a plant. And they're high stress, but it's a lot of fun when you finish. And you can come out of it and say, well, I did a great job. Your customer loves you because he's out of a problem, and he respects you because you solved his problem. You made his business easier. And that's all you're really trying to do is make your customer succeed. Because if that succeeds, everything else falls in place. But yeah, for somebody getting into this or thinking about it, just look around. If it moves, if it's flexible, it's a thermoplastic or an elastomer. And say, okay, geez, what's the problem with that? Does it kink? Does it crack? I bet you if there was some way to make that work, what can I do differently? You look at a tire on a car, if it gets all cracked along the outside, boy, there's got to be something that stops that from happening. And it's just being innovative in your mind, even if you don't have the answer, then working on, geez, that's an engineering discipline within an elastomer field that we can make work. And maybe you don't have the answer now, but if you think about it, you'll come back to it. And if you're in the field, it'll be a lot of fun, because it's like having the best toolbox in the world. And you can. I was going to get into cooking instead of elastomers, but this is all the same thing. You're putting all these ingredients together to make completely different things. You can make omelets, or you can make cakes or cookies, and sometimes you flop, and sometimes you really have a lot of fun learning from your mistakes as well as your successes. So yeah, that's what I really think you need to do, is have the mindset to want to make things better and then figure out later how you can get there. I learned a little bit about it in college, but it was happenstance. It was just a choice. I went to a company. I had 3 or 4 offers. 3 of them were out of state, and 1 was in the state. And I said, you know what, maybe I'll do one thing at a time. And that was Uniroyal was in Connecticut. I had 2 offers at Dow Chemical and 1 at ICI, which became something else out in Delaware. And it was happenstance. I learned a lot, and you just take it from there. It goes a lot further. It really doesn't make any difference what you choose. It's the mindset of how you want to change things. I mean, you go today. I mean, you can. It's kind of funny, because I do this all the time. You go to a hotel room, you look at the shower head, and sometimes you see these little inserts. You say, oh, that's silicone there. Well, it's silicone there because the minerals won't deposit on it, so they keep clean. The old ones, which were all metal, used to get after a while, you had to put them in vinegar and stuff just to dissolve it. So there's all little things that you see, and you look and you say, wow, what is that? Why are they doing that? But yeah, it's kind of a fun. Silicones are fun because they're used in very low temperatures, very high temperatures, and you can make them any color under the sun. Other elastomers, you're a little bit more limited, but they all do have a place.
Okay, where do you see this industry heading?
Well, I saw that, and when I thought about where the industry is going, you really break it down. I break it down into 3 areas. The first one is applications, and that's the most exciting one, because what we're seeing is more and more specialties of where elastomers are being used. For example, high voltage insulators were porcelain for decades, if not centuries. Now, then they went into EPDM. Now they're mostly silicone, and it's amazing to see that transition and how you can change the whole industry from one to the other. As I mentioned earlier, a lot of your kitchen appliances have gone from metal to plastics to elastomers. So there's a lot of applications. A lot of the new ones we're seeing now are subsea, very critical applications, not highly technical, but if they fail, it's millions of dollars of business that people lose. There's insulators. A lot of the stuff at the bottom of the ocean, when you're out down 10, 15, 20,000 feet, that environment is foreign to most of us, and it's trying to understand what the material needs are, what happens to elastomers under high pressure as they start compressing. So it's kind of interesting there. As we mentioned, LED lighting, billboards are changing from flat panel print to slideshows, and that's always interesting. And then the healthcare, the more and more products are being used in medical devices, and they could be elastomers, they can be plastics, but it's interesting the needs and the short-term, long-term implant for devices and what you need to do. I mean, everything from the wire coatings on a pacemaker they're implanted for a long time. The pacemakers used to last about 2 or 3 years. Now they last 20 years. So now all of a sudden you've got material that has to be exposed to different environments, either inside the body, outside the body, or on the bottom of the ocean. Aircraft is amazing. When you fly a plane and you look at the outside temperatures minus 60 Fahrenheit, you say, well, it's kind of chilly out there. I hope that rubber is staying flexible. And so that's where I see the application part. The second part of where the industry's going is increasing global competition. And it's not just a foreign company making parts and trying to dump them in the US or in other countries. We're seeing US companies building manufacturing in Asia, in Europe, in South America to supply global. There's two parts of that. One is you get caught up with the regulations of every country because you can't, if you're selling a product here, it may not be acceptable in Europe or in Asia because they have different country regulations or group country regulations as in Europe with REACH and ROSE and these other organizations. And what you have to do is know up front if you're developing a product and by working with your customer, are they going to be making it here? Are they going to make it in the US and other countries? Are they going to be making it here and selling it to other countries? Because that has an effect. Because now you have to understand the regulations that go along with that. And that's getting more and more difficult. South America is picking up quite a bit. Brazil has expanded their elastomer usage quite a bit. And it does come into play because there they want local manufacturing. So all the companies from all around the world are going into Brazil so they can become a local supplier in Brazil. And it's interesting to see how that changes how you have to supply those companies in that country. So that's kind of the biggest thing is that global competition right now is getting harder and harder. The last piece of it is, and it's not, it makes sense when you hear it, but it's not something you think about first, is understanding your customer's mission in the business. Do they want to be the mega low-cost supplier to this industry, or do they want to be the innovators? That has a big aspect of how you develop products for them. If they just want to be the low-cost supplier, you're not going to give them a premium product that they see no value in. With one exception, if you can go in and say, hey, I can make this product, it's going to be 5 cents a pound more expensive, but it'll run twice as fast in your plant. Then they say, okay, that fits to my low-cost structure, and that's how you deal with those customers. But typically, you're working with commodities or process improvements. The innovators are the fun guys to work with because they're looking ahead. They want to see where the applications are going, what's the next hurdle that they need to work off of. And those are the people that work very closely with you to understand all aspects of their business, their customers, the applications, and their process, and we put all those together. Now, part of that as well is understanding that the end user, he's only concerned with one thing, or he or she is concerned with one thing, product performance. If it works, if it's within tolerance, they don't care how you got there. The fabricators are mostly concerned with process. How do I get your product to give me the highest yield running through the plant in the quickest amount of time with the least amount of steps? If we can solve that, our customers are thrilled. The end user doesn't really care. He's getting a better, maybe a cheaper product because they can run it quicker, but his concern is really the performance. So it's balancing out what you're supplying your fabricator versus that. I always touted it as the specification, which is what the end user is identifying, that's your ante in this poker game. But really playing the game, once you get the ante in and you have the product that meets the spec, is really the process of the fabricators. And that's what I like to work with is, I can't make it cheaper because that's easy. That's marketing can do that, sales can do that. But understanding all the steps he has to go through to make your product, if I can skip a step, if I can increase yield here, that's got to be money in your pocket. If you can measure that, I can save it for you and not have to give away the farm to make the product cheaper just to compete. So I always like it as, if we're competing against price with somebody, I'll say, let's not talk about price. Let's talk about what's your steps, what's your bottleneck. If I can make this stuff, if you're injection molding a part and it was running a 2-minute dwell and I can get it down to a 1-15-second dwell, can you measure that? Well, there's less energy, more parts in the shift, and maybe he doesn't have to buy a new piece of equipment as his business grows. That's all money that he can count on that's in his pocket that has nothing to do with the end user. So that's where I like to look at understanding your customer and their product value and their process value, and deal with that. The end users those are a little bit easier to deal with because we have a spec. If we meet the spec, we're on a print or we're an approved supplier. But the process is really the tough part of the business. So that's where I see another part that's really gaining and gaining. Before it was just there was so much fat in the price. Yeah, okay, if you don't like it, we'll just drop the price. It's not there anymore. So we really need to take that next level up where we're working on the process instead of the price. You know, I can joke about it and say, well, the one thing I didn't realize is that I had made a lucky choice being in the industry, because I haven't really changed out of the industry in 41 years. But really it's what you make of it, really. I enjoy working with people. I enjoy working with customers, even if they hate me and my product. When I come in the door, we build a relationship, and we see that. You get to a show like the Rubber Division show here, and it's amazing that the customers will come up to you, and you're joking like you've been best friends for years and years. And you know, you remember the times when they were hollering at you and screaming at you about your product doesn't work and your mother dresses you funny. And so yeah, it is getting back to that relationship. And I didn't realize, I thought it was going to be more cut and dry, and didn't realize how important that was. Luckily, I didn't have a problem talking to people, so it was easy. But it was important from a lot of aspects to work with a customer as if it was a friend, trying to help them out. And you know, when you start in this, and when I started in this, it was just pure polymerization. It was the next step from a lab with beakers and test tubes. We were working at a small pilot plant doing solution and emulsion polymerization, and learned a lot about the chemistry of the rubber, and knew I needed to know more. I needed to know where it was being used, why it was being used, and what effect could I put in to what I can control to help the customer out, even at that level. And so it was really getting out early, you know, probably after a year or two of working in a pilot plant, getting out to customers and understanding what they needed and what would benefit them as well. So that, you know, we tried to learn that in college a little bit, and troubleshooting and understanding processes. But when you're in it, it's, you know, because you learn it like this, and then you live it in this, and it gets a little bit more difficult to make that connection. But once you do, I mean, it's great. I mean, that's the fun part of this, is connecting with the customers and what they're trying to do. And it's not for everybody. Some people, you know, I've had engineers come back and say, that guy is so stupid. He doesn't know what the hell they're doing. He's been in business for 40 years. He knows what he's doing. He's making money. Let's figure out what he doesn't understand about what we're doing, and let's help him. Let's teach. Let's understand his approach and his position on it, and work it out. But, you know, to come back and just say, well, be negative, it doesn't help anybody. So I enjoy working with people and understanding where they're coming from and what they do. It's fun. I enjoy it. Every time I go to one of the interesting things, every time I go to a plant for the first time, I ask for a tour. And they say, well, you know this. I says, no. This customer, they're proud of what they do. You're in their house. They're proud of what they do. They want to show you the uniqueness of their process and what they do well. And it's good to see that, because first of all, you get to see how they approach maybe a similar process as somebody else, but they do it a little bit differently. But they also respect you because you're interested in them and their process. So it's a give and take, but it's always fun. And even though I've been to, you know, dozens and dozens of fabricators who injection mold, maybe this guy does it a little bit differently, or maybe his post process is a little bit different than the normal. So it's fun to go out there and get them. They're so willing to share, because they're proud of what they do. You ask them, and they want to show you everything they can. So that's the fun part, and it's good. And yeah, I think that's what I never expected early on. But it was nice. And it was, once you understand that, you become a better, really, supplier out in the field. Never give up. There's always an answer, and never say no. Because, no is just an excuse. And we've had customers like that. We've had a customer of ours, a company I worked for in the past, who wanted their compound, the compound they were going to mold, be put in a refrigerated truck as soon as it was finished. And our plant would say, no, we can't do that. I said, what do you mean you can't do that? Well, we'd have to have power lines. We'd have to. I said, yeah, so you can do it. It costs money. We're not asking you to make a decision on what it's going to cost, but what can we do? Don't say no. There's a cost, and if the customer feels that that cost is worth it, they'll pay for that. You're not going to. It's not going to come out of our pocket because he's asking for something special. So, the one thing I would say is never say no, and think about, if I don't say no, what can I say, or how can I approach the problem to fix it? Say, oh yeah, this is maybe I can work for somebody else and do the same thing. That's not the fun part. The fun part is getting out and seeing. But yeah, and it's like I said, you can either come into a customer and go beat heads, or you come in and say, hey, I want to be part of your team. I want to be part of that solution. And we have a customer now that is a multi-million-dollar account for us, and I visited them probably starting about 10 years ago. The first thing they asked me while we were coming and talking about something, they said, can you look at one of our formulas to see if there's something wrong with it, because we're having a lot of trouble. And they said, well, it's not your material, but can you take a look at it anyways? And I did, and I said, oh yeah, there's definite ingredients that are conflicting here that you really should have one or the other, but not both. So they took them out, and the problem went away. They said, we've been struggling with this for 6 months. They said, the next time we get a new job, it's yours. And it's grown. It's grown, and they don't forget it.